The topic for our BE project is Smart Parking and Number Plate Detection. Guide for our project is Dr. M.D. Patil sir, and the group members are as follows: Neha Gupta, Pooja Gupta, Shorjo Sen and Sunny Kadam. So the table of content is as follows. First we will define the problem, and then what are the objectives, introduction and other details will be explained. The problem definition. With increase in population, the number of vehicle increases, and due to unmanaged parking, it leads to wastage of petrol and time. The objective for our project is to reduce the time for finding the parking slots in any parking area. It eliminates the unnecessary traveling of vehicles across the filled parking slots. So what exactly our project? An IoT-based car parking slots monitoring system is built using Arduino, Node MCU, and Blink application. The parking area is divided into two parkings, that is parking 1 and parking 2. Each parking has 3 slots and every slot has one infrared sensor. So we have a total of 6 sensors. Each sensor is used to detect the presence of car in the slot. These infrared sensors are connected with the Arduino. So when a car is parked in the slot, the Arduino sends a command to Node MCU, and then that command is sent to Blink application. So now coming towards the IR sensor. The features of the IR sensor is explained as follows. LM358 is an operational amplifier used as voltage comparator in the IR sensor. The comparator will compare the threshold voltage using the preset, that is pin 2, and the photodiode series resistor voltage. Photodiode series resistor voltage, when it is greater than threshold voltage, then op-amp output is high, and when the threshold voltage is greater than the photodiode series resistor voltage drop, then the op-amp output is low. When op-amp output is high, the LED at the op-amp output terminal turns on. That indicates that there is an object in front of the sensor. The VCC pin is connected with the Arduino's 5 volt. The ground is connected with Arduino's ground, while the out pin is connected with the Arduino's out pin. While the black and white LEDs are of the IR sensor, in which one is transmission and other is for receiving. So now coming towards the Node MCU module. The features are as follows. This is the Node MCU ESP8266 Wi-Fi module, which helps in monitoring of the car from anywhere around the world. And one major recommendation is never power up the Node MCU Wi-Fi module with Arduino's 5 volt. If you power up this module with Arduino's 5 volt, then the Wi-Fi module will keep resetting. To solve this problem, design a separate power supply of this module using LM7805 voltage regulator. Now we will discuss the features of Arduino. 6 infrared sensors are connected with Arduino pins 4 to 9. The infrared sensor VCC pins are connected with Arduino's 5 volt. Ground are connected with Arduino's ground, while the output of all the infrared sensors are connected with pin 4 to 9. The Node MCU module transmission and receiving pins are connected with pin 2 and pin 3 of Arduino, while the V-in pin of the Node MCU is connected with the output of the voltage regulator. This is regulated 5 volt power supply based on LM7805 voltage regulator. Now we will see the circuit diagram in which the sensors are connected. The 6 sensors are connected, that is 3 in parking 2 and 3 in parking 1 with the Arduino, and this signal is sent to Node MCU. The Arduino programming flowchart. First, we need to open the Arduino, import libraries, write software. Then we define the 6 pins, 6 variables, create 2 functions, that is void setup and void loop. We set the baud rate for void setup and Node MCU at 9600. Then we create the void setup function, which has the pin name and status. In void loop, there are 6 user defined functions. Each function contains 2 if else loop, digital read car, digital read low, that is car is present and sensor value is 255. Then the last part is serial println and Node MCU println, which is used for debugging purpose. Blink application. Now we will see how the flow of Blink application works. First, we set up a project in Blink app. Then we open the Blink app with and we register it with an email ID, and then we log in. Then we create a project. After that, we choose a device here, which is Node MCU. It will send an authentication token to the registered email ID. Now we add the widgets with the widget box. Then we configure the 6 LEDs with the virtual pin. Finally, we reposition the widgets and resize them. These are the libraries used in Node MCU. After that, we will play a video which will actually show how the car parking works. As we have placed an obstacle, that is a car in our case, then it shows that an obstacle is present and the slot is filled. After that, we do the same thing with the second sensor in parking 1, and then we can see that the car is parked and the place is filled. Same with the third slot. Now we can see when a number of obstacles, that is cars, are placed in the parking, then we can see that the slots are filled. Here we can see the whole parking is filled. The other part of the project is automatic licensed number plate detection, which will be explained by Shorjo Sen.
We need to do installation and setup. So we need data various different number plates so that we can collect the data, and accordingly to that we can build our project. And on third step, so we need to train our model in order for the model to appropriately detect different types of number plates, and it can provide us accurate information and give proper results. And after that, in the fourth step, we will be detecting license plates. So through our webcam we will throw a license plate, and it will detect that the following image is a license plate, and it will show the accuracy also, that how accurately the model has detected the license plate. On step 5, then we will apply OCR to text. So will extract the text from the license plate and we will display it. And on step 6, we will show the only the region where we want to highlight our number plate, and only for that region we will get the results, and then we can display the output. Once we have opened our Jupyter notebook, then we need to click on training and detection. Majority of the work we will do in the training and detection. So the first step will be setting up our paths, and first of all you need to check whether your kernel is set to ANPR sys. So we had created the virtual environment in ANPR sys, so we need to change our kernel to ANPR sys, and then we need to set up our paths for the project so that we can execute our code properly. So just to execute all of these codes, so just click on shift enter, and you will see that the paths are properly being set up. So if we go to our D drive, we had created this folder ANPR. So you can see all of the folders have been set up properly. So this is the role of the first step, that is setting up the path. On this next step, we are going to tune our pre-trained models. So whatever models which are trained, we are going to tune that, and it is called transfer learning. So in this step, we are going to do that. So first, we need to import this library called vget to fetch the pre-trained model. We need to work and we need to collect the data in order for us to work on this model. So first of all, you can go to a website called kaggle.com, and there will be data set available for us. We need data set for car license plate detection. So you will find plenty of images regarding this car number plate, and you can download this data set, and there are annotation files as well as image files as well. So you can download this, and afterwards you can go to Jupyter notebook and create a label. So that means you can create label as license over here, and since we are creating only one label, so we have written id as one over here, and we need to execute this cell over here. And after that, once you download the data set, then you will find this folder over here called images, and inside images you need to create two folders, which is test and train, and you need to copy some of the images from image folder to test, and it contains all the image file as you can see over here, and this is the annotation file. So it is given the size of the image, width, height, depth, and all of the details like name is we have defined the label as license, so here it is given license and all of these parameters over here. So these are the annotation file, and see, likewise there are images and annotation files in test and train folders. You need to separate. On step number 6 we need to train the model. So according to the number of steps we want to train the model, you can write 10,000, 5,000. So if you want better accuracy and of the model, so you can train it to more number of steps. So for this example, we have trained our model to 10,000 steps, and just click on shift enter to run all of the cells over here. And this is the command, as you can see over here. So just you need to copy this command and just go to notepad and open a new command prompt, and then we need to navigate into our D folder because we have created all saved all of the project files inside D, and then go to ANPR, and then we need to activate our virtual environment by using the script called dot slash ANPR sys slash scripts slash activate. So we need to train our model inside the virtual environment, and after that copy the script from this over here, that is train the model, and then you need to paste the command over here, and if you click on enter, then it will take some time, but uh, it will train the model, and it will help it to properly accurately detect, and it will help you to appropriately detect the model, and also determine how effectively and efficiently it will work. This step helps you to locate the location of the image. As you can see over here, this image is inside the test folder, and you need to write the name of the image with the extension. So for our example, if we look at the test folder, you can see there is an image called cars 416 and the extension is .png. So after that, if you just execute this cell, so this uh, gives you all of the information about the images over here. That's how you can create them. The next step, we are going to detect an image. If you run this cell, then it will help you to detect the image with accuracy. The next step, we are going to do real-time detection using our webcam. So if we run the cells over here, then it will open up our webcam, as you can see over here. As you can see over here, it is allowing us to do real-time detections when we are showing up a number plate image on our webcam. Code, as you can see over here, scores, list, filter, detection, threshold, it allows us to check that the whatever detection has been done by our model, whether uh, how much uh, how much is the score of the detection that is displayed through detection threshold. This is the code which is written to apply OCR on our images. As you can see, for IDX box, it will help us to loop out the boxes, and it will allow to select the region of interest which we want, that is the number plate in this case, such as height, width, and all of these parameters which are required for the number plate. And if you are going to run this, so as you can see over here, this is the OCR has been performed on this number plate. So you can see G526JHD, and you can see all of the coordinates over here, that is height width. So these are all of these coordinates, and you can see that the text has been extracted exactly as we wanted it to be. So this is how the OCR of the number plate has been performed successfully.